All right, now doing D, where we are asked, suppose we choose two closed intervals U from A to B and V from C to D uniformly at random from negative n to n. What is the probability that U is enveloped by V, meaning that U is a subset of V, and for this to hold, we need C to be less than A is less than or equal to B, and then B is less than D. And then what's this probability as n approaches infinity? So first, let's look at what our what's going on here, right? This is a pretty loaded problem. So first, we have to find out what our sample space is, which we get from choosing two intervals. But first, we need to figure out, what does choosing an interval even mean, right? So from negative n to n, you know that there are like 2n plus 1 total slots, right? And an interval is uniquely defined by choosing one point at one integer as a start point and one integer as an end point. And we can kind of think of intervals as like partitions between these 2n plus 1 integers. And the total number of like partitions or bars, I guess you could make, is 2n plus 2. And to make an interval, we're simply just choosing any two bars, any two slots of our partitions to make an interval. And to make two intervals, we are simply just doing this twice. And so we are squaring it. And that gets us our sample space. So now we know the total number of ways we can choose two intervals, but how many ways can we choose intervals where like we need that equality C is less than A, which is less than or equal to B? Let's write it out. E is less than D. And while this does seem pretty complicated, it's really not that bad because we know that there are 2n plus 2 possible intervals that can be made here. But for our intervals to kind of be enclosed as this problem wants, right? We always need to pick every time we pick like 2 points for an interval, it's kind of just like chosen, or it's like we don't need to worry about reselecting it or anything. So every time we choose a slot, as long as we're like choosing any four slots, right? Like for example here, this would be like C, A, B, D. Then another example I could do here, I guess, would be like C, A, B, D. As long as we just choose any four slots from our 2n plus 2 possible slots of partitions, we are going to end up having this enclosed interval, as we can see here. We just need to choose four slots. So that's just 2n plus 2, choose 4. And then now to get the probability of choosing choosing intervals such that we we have this enclosed interval, we simply just take the number of possible ways that can happen, 2n plus 2, choose 4 over our sample space, which is 2n plus 2, choose 2 squared. And I'm not going to get into the algebra of it, but this simplifies to 1/6, or like it'll end up being this large expression where n to if you were to take n to infinity, it will approach 1/6, which means that the probability would converge to 1/6. And that finishes 2.2. See you guys next time.